The challenge here is that we need to find a system that powers our analytics system. And this will be the drill of the presentation. And let's see the challenge. So the challenge is that we need to find a system that does the basic operation of the database, but it let us do deep analytics on a large, multi-source, complex, unstructured, so not only columns, even JSON, and it's a hybrid stuff. Be real time. We will define what means real time, or actually everyone on the project defines the real time. Be terabyte scale, cost effective. Costs are important also when you are in a database business. And run ad hoc reports, and without developer, which means that you create a system that an analysts can use their tool to run the query that they constructed on your system without creating performance impact on your service. That's the ultimate goal. And withstand Black Friday, so a lot of events, and have preferred SQL, JavaScript that everyone knows. And let's see what we can use to do about this. So Einstein said that we can't solve problems using the same kind of thinking when we created them. So if you look at the legacy system, we have a source of events, probably a web server. I'm mostly in the web part of the business, so most of my examples will be using the web, but you can take as a product as well. And to have reporting, you end up creating a scheduled tasks on Linux crons, and actually you run in the midnight of kind of preparations for the report, and you probably end up serving a cached version of the report. I see that you are moving heads, so actually I lived this era, but from now on I am not living it. Behind the scenes, days to insights. I also don't count that the developer needs to implement the report and everything else there, so it could be 1 week or more. Let's see what's here, what this means. So minutes to kick in, that processing is minutes to kick in. If we just take crons, that's the minimum is 1 minute. But if you have a reporting system and you need to run every minute a cron, that's actually a pretty intensive job there. You need to aggregate, clean, that takes hours, pre-processing and everything. And you end up days to the insights, which needs to be changed. We need to find another system for this kind of tool, or for this kind of problem. Here we have our desired system. It should be terabyte scale, real-time raw ingestion, so we should not spend time on batching and sending in batches. Ask sophisticated queries, and query performance should be a feature, or it should be actually something that we can rely on. It should be low maintenance, as if you have a large system, probably you are running multiple nodes on your database system, and you need to do a lot of DevOps and sysadmin things. Cost effective and wire them up easily. So actually, I will show you here how easy it is to add BigQuery at your system. As equipment strategy, some projects need in-house, some hosted, some managed. I will talk about a managed system, where what that means, you are giving the credit card and you don't own a virtual machine, you don't own a machine, you actually bought a service. And you don't end up using all that energy to operate the servers and do all the maintenance stuff that comes behind. We can use MongoDB, Elasticsearch, Hive, or recently Amazon Athena, but I will spoke about Google BigQuery. Our ultimate goal is to store everything accessible by SQL immediately. So Google BigQuery, who uses Google BigQuery? Who have heard about Google BigQuery? Good. Okay, great. So what is BigQuery? It's an analytics as a service from Google. It's on the market for 5 years, I think now, and it's fully managed by Google. So actually you don't have servers to say so, scales into petabytes, and for example during this Voxed Code presentation Google has the cloud conference in San Francisco, and they showcased the full day of enterprise customers that presented their implication in BigQuery, and the large companies, even Yahoo, is using Google's BigQuery to analyze petabytes of data. So it's something in the petabytes system. It's ridiculously fast. It has decent pricing, and actually here what's actually amazing, because I couldn't believe when I see the pricing. And so for the storage, for example, if you have 1 terabyte of data, you pay $20 per month for a terabyte of data, and if you query 1 terabyte of data, you are paying 5. And if you load data, that's some loads are free, streaming inserts are some cheap option there. It has all the CQL 2011, which we know now from Marcus what features it offers, all the support. You can write JavaScript UDF. It's amazing when I heard that I can write UDF in JavaScript. Today we have presentation about Spark and other machine learning presentations where they crafted the transformation and worked on text and split and reorganized. What if we could write directly in JavaScript, which we probably already know how to write it. And it has all the familiar DB structure things, integrates with all the Google products. So for example, you can keep a table on Google Sheets, for example, and that's what is important. For example, what we use for, sometimes the analysts want to aggregate by her own type of report something, and I need to create a table to use as a mapping table, but I don't create a table. She creates the table on Google Sheet, and actually she can wire in the query for that. And whenever that table is updated, it's automatically reflected, so there is no maintenance stuff. You just create the sheet and that's it. Okay, and clients available in your favorite language. Conveniences of CQL, columnar storage, 10,000 columns in a table. Yes, it is. Since it's BigQuery, you can use 10,000 columns in a query. You have the rich SQL, you have JSON functions. Those are actually my favorites, because in a column I can store JSON representation of data of a document, and later I can process whatever field or whatever thing I want to do by SQL or by JavaScript using the UDF notation. It has all the fancy data types, even nested records, struct arrays, so these modern things are there. And it's append only, so it's not a database that you frequently do update and inserts. So actually you are doing only inserts. DML, update, delete is allowed, but it's limited. They want to force you in using append only and think in an append only manner. You may be afraid about the append only, but since it's BigQuery and it's cheap, you can, for example, on every profile update of the user, have a new entry in your database, ending up, I don't know, with 20,000 updates for a user in a year. But you have a function to take out the last one, and for example, you have analytics to optimize between the phases of the feature. For example, we implemented something that we seen from the updates of the user, which is actually also a stream, because every update operation is a stream. We measure that selecting the country field is longer than the others. And actually we reason back that there is a long select where they need to select the country. And the user experience team come back with the option, let's put 5 very very big countries in the first phase. We resolved for them the problem they had at their occasion, and we, with the metrics, with the insight, we were able to do that. You can load batch load files up to the 5 terabytes, which is absolutely brutal. I cannot create that large file, for example, so far. And you can have access to day partitioned tables. Why it's used to have day partitioned tables? It's day, it's not date, so they allow you to have a day partitioned table. It's important because you pay the queries, you pay what data you touch, and when you have your data in every day in a separate partition, then you're paying only the data that you are actually touching. You are not doing a full table scan to say so. So if you have 3 years data and you do a aggregation that you need 90 days, you are actually can reference that partition and only pay that amount of data. Okay, so costs. Since it's a managed service, we need to talk about the costs, as we are giving our credit card and full trust in Google. So first of all, we have a free thing. So actually, if you go home and you take out some queries from my side, or you find a lot of public data on BigQuery and all the queries, you can wire it in, and up to 1 terabyte you can run free your query. Make sure that it's only under 1 terabyte, as there are some public queries that are more than 1 terabyte, and with one single query you can take out your free limit per month. But that's a showcase there that they can run more than terabytes of queries. So I will dig in that. So ingestion, so batch load from files, it's free. Exporting is free. So if you want, for example, take out from BigQuery to Spark something, you can request an export job, and that export goes to the S3 type of Google. So they have Google Cloud Storage, which is the exact similar thing, and goes there. And for example, you can look it and move it forward with Spark as well. Table copy is free. And let's see, so for example, if you have 5 terabyte of storage, you stream 1 terabyte new information in the same month, you run 3 terabytes of query, you are having this amount of costs. Where can you buy for $165 machines that power you this amount of data? I don't know yet. So for example, if you have 25 terabytes, you have this amount of data. If you have 1 petabyte, you have $22,000. It's amazing. So let's see how we think wiring in your system. So we have the on-premises servers. You could be the cloud, but I represented as on-premise, and probably you have a source for your events. What you have so far probably is that you have the platform services. You need to implement event sources, and maybe with that occasion you also stream your metrics and logs for further analysis. You use a pipeline that you actually install in your system to actually forward that information to BigQuery, which is on Google Cloud Platform. So if we take this chart forward and we add in persons, what we notice is that the developer is working on the on-premise server only, and its task is only to add the pipeline, and actually the pipeline makes sure that they still follow the same logic and they have their own database still running the business. So this BigQuery is complementary to the traditional database system, but since we live the abundant storage era, and it's cheap, we can afford having a copy of our data on cloud, for example. And in the end, having all the data in the BigQuery analytics backend, analysts without your support, with using tools like Tableau, Quickly, Data Studio from Google, amazing, or the internal dashboard that you have created for some metrics, or both wired in together to have access to the data. Often we don't create developers. Often we don't create tools for analysts that let them in our system wire in or construct dynamic queries, for example, in the interface. Why? Because if they end up constructing something brutal, all our backend system is down and it's not optimized. So, but having this system, it's easy to do and let them, because Google takes care and runs on their infrastructure. Okay, let's move another level. And with that level, we name actually here the devices. So we may have the desktop, the mobile, and actually some sensors. We are living the Internet of Things movement, and actually we have a lot of sensors. For example, an autonomous car, it's generating 3.8 gigabytes per second data for all the sensors. They dump the sensors data because they cannot store it. They could store it, but they cannot ship that fast because we don't have yet 5G GSM network. When we will have 5G GSM network, they will be able to ship 3.8 gigabytes and more data in real time to the cloud. And we have events monitoring and logging. We do the pipeline. I will mention FluentD. Currently, if you were in this room, we discussed others mentioned today, Kafka, Storm, Stream, and lots of other functions. I choose to use FluentD, which is a minimal example to showcase my problem, and actually it's very easy to wire in. So what you do here is that you have this router that actually does two things. The same event is actually going to your servers, so actually you are doing, and you are actually, you don't need to modify your server and your application to behave as it is now. It does the connection with your SQL database, for example, and it can run. What you added is that you added the FluentD component to be as a middleware here. And also you make sure that your application is written with events in mind. With events in mind, what that means, I define a JSON, and actually I use a curl call to call, for example, FluentD with my information. FluentD I can have on the same machine, I can have as a cluster, and I can make with FluentD another code backup, for example, as actually here it does three things because it archives on cloud storage. Why we need to archive? Maybe someday a not named company put out on the market a better service than BigQuery and we want to migrate there. We will have a copy of all our events on file and we can actually replay it. Or for example, if I want to take out some field that I have in JSON and I want to represent in different format, as I don't know, a country is changing currencies in Europe, we will have this issue as Hungarians may move from forints to euro, and you need to wire in and actually rerun your database to do some information there. You take out the file, you play back to the same pipeline, actually it spits out the data forward. And Google, since it's interconnected, all the Google services are interconnected, they let you to export their services raw data to BigQuery. Google Analytics, you probably are aware that it's a sampled data. So you are only seeing sampled data and you are don't seeing per se. And for example, in Google Analytics, you are don't dealing with persons. It's very hard to track individuals. You need to add custom metrics, but if you add custom metrics with the sampled, all the logic falls apart and nobody does that. But if you have, for example, access to the analytics data using BigQuery, you could implement per person tagging in Google Analytics and you would have access per se for every raw data and you can do all the fancy stuff like that. Firebase, it's very, very popular on mobile applications where you build applications and all the interactions and all the events and metrics and sensors data can be tracked by the Firebase, and the Firebase team exports the data into BigQuery. The amazing thing is that if you have a copy of your business data in BigQuery, you are able to join them. Since we are talking about tables, you are able to join my own business table with the analytics table, and actually I can end up using something from the analytics parts and wire in something. It's amazing, the possibility. Actually, we end up thinking, what could we take out from our system as an insight, what we can do. I'm dreaming a way that actually we will have sometimes a database system that it will be a central point for every data, and whatever I push in there, I'm able to store and actually wire and join and whatever. I think we have reached that point with the BigQuery. FluentD, I mentioned it's the minimal simple situation. I have 4 cases here. It's this configuration that you need to put in FluentD. So if you install FluentD, after that you need to put it. You have a filter for the key that's coming in. You have a type, that's the action that's happened. On the same event, I have here additional jobs for it. And what I do, here I enabled a Ruby subsystem, and I can run here Ruby code. And actually, I'm creating a BQ record, where for that record, I set insert ID host created with those fields. This BQ record didn't exist in the JSON that the user sent for me. I ingested now. And I removed the key host. That's just an example of what preprocessing is possible, but with the Ruby you are able to preprocess whatever you want. Later I created a multi-step rule here. I created a copy, so the same event it's copied to multiple outputs. I'm using here the file, so actually I put them in a 10-minute aggregated file, all the JSON entries for archiving. And I am shipping to BigQuery with the streaming insert. For BigQuery, I created a service account, which I can download from the cloud. It's a file. I put it here. I name the project ID dataset. I name the timestamp field, slice, and the table. The table, it's important that with the $sign, I name a partition. And there actually I am ingesting data in a partition. I mentioned earlier that using this technique would allow me to save costs more, as I will have partition by day. And I have a schema for the table, and I have ignore unknown values. This ignore unknown values is actually a feature that I like. I usually construct my BigQuery tables like this. So I name the columns that I want. Some columns are repeated fields, and some columns are records. So actually, they have sub-attributes for that. For example, I no longer have a single column country ID. I have a record with country ID and the name at that time. Sometimes I need to run a query where I need to display the name of the country. I can quickly use from the table. I don't need to join to get the table. Of course, when I need up-to-date information to get an updated country name, I need to join. But these are situations when I can balance between the solutions. Since the storage is cheap, I can afford setting another field. And I know that performance-wise, no change here. At the end, I have a meta table, a meta column, where I put all the JSON information I didn't put in the columns, which is another important thing, because at the application time, at the runtime, when I have in my application, I don't know, access to 200 attributes of the field, I may be passing 10 in a column, but the rest of the 190 maybe I will use in the future, and I'm wiring in a JSON column, for example. And later, if I need that field, I'm taking with the JSON function out, and it just works. Since, again, it's cheap, I can afford that. Its performance, I don't see the change, because only when the impact, because when I touch that field, then I see the impact. So where to use BigQuery? We use on a data that's difficult to process and analyze using traditional databases. Unstructured data, that's my JSON column at the end of the table. It complements the system. So you still run the framework, the stack that you want, but it complements the analytics part of the system. Applying JavaScript UDF is amazing. So for example, I could take a natural language processing library and put the full JavaScript output in the UDF, and actually I could run all the advanced analysis inside the UDF. It's important to know that this UDF thing, it has this emit thing, so it comes something in like a row, and it emits 0 or more rows. And it's important to know that 0 or more, you can emit nothing. So if you done a condition in a UDF, you can delete that line from the output, or you can transform one row into multiple rows and actually emit multiple things. This is also important, as sometimes you need to, like a sentimental analysis thing, you are running a JavaScript engine on a text and you are enriching your output with sentimental analysis. I am happy, it's raining, I'm a conference. It's three tracks this time, but next time it may be 10 things. Okay, so what you should do when you go to home, find the BigQuery project. You need to enable billing, that's your credit card. You need to enable the API, and then you are presented with an editor. And in the editor, you can type in this query, for example, because this is a public data. Google has a lot of public data sets for public access, and it doesn't cost you the storage. And you can analyze those databases. There will be slides what public data sets you have access to. In that query, you see that it took 2.3 seconds for 3.5 gigabytes. The system, even for 10 megabytes, it responds in 2 seconds. The system for 100 terabytes, it responds in the same for like 10 terabytes. So it's not linear. It's a big data tool. So even if you have 10 megabytes, you need to wait 2 seconds. It's not a real-time database. You cannot replace MySQL or Postgres. But you can be assured that if you wire in a big query there, like a long query, then it will take that amount of time, even with small data set or even with bigger data set. And that's a good feature. So for example, here is a query which I actually put together. Let's see that in 2016, what was the number of days that they had snow. You probably recognize the places and that. So this query also, it processed 3.2. It cost 1.5 cents. And it took me 4 seconds. Okay, what we achieved. So, REA in Târgu Mureș has a lot of projects, cloud projects and startup projects. And we need to actually fast respond to startup needs. They have a lot of insights, need of the insights, and we need to act quickly. With such a system, we can do funnel analysis. Often you do this in analytics, in Google Analytics. But you cannot track down to the persons, for example. And here is a table or a minimal query. It's a pseudo query that actually tracks where the user, what steps the user did achieve. In analytics, you would have construct a goal, and actually you would be wired in the Google system. But with analytics, we could wire in something. So I explain briefly the query. So I'm using the session ID to identify a user path on the rows. I'm finding the first one, sign in as step 1, sorry. Step 2 the same, so I didn't completed the query. And actually I'm comparing here timestamps 1 to 2. There are better ways to write this query. I just showcase that I have one query to pick the first step. I have another query to pick the second step. That happened later. I have another query to pick the third step that happened after the second step. Why I put this query together? often programmers who are working on a mixed projects are not super database experts like Marcus is. And they wire in or type the query as they end up first time in their head. They are not doing research that what optimized way to do are. And I can let them. It's not good, but team leaders can let if there is a system that is responding decently for this system. And it will be longer. So for example, often we have 200 lines of SQL generated, of course, or some written by hand using this technique, and I can name 300 steps, or actually 20 something was the maximum which we named a path, and we could able to X the table what the user think and actually measure things. Okay, if you have a chain of hits, for example, for a website hit, you could have a request that let's find out that if the user visited an order or actually created an order page, how to compensate the affiliate. Suppose that we have an affiliate system. That means that the affiliate system has an input for an article page. And I need to go back and actually find out which article they visited first time before taking the order. And the first article, because in the loop there will be multiple articles here. For this situation, you would create a separate system. You probably store in Redis all the metrics where the user landed up from the analytics side, and actually keep tracking of all your inputs as analytics and inputs of affiliates, and you never know which them converted to orders. But having all the hits as a separate event as a row in a database system, you end up running a query. It uses the technique that Marcus mentioned, so I'm numbering the hits. I'm actually then taking, so here are the hit index, the first numbering, then based on an example regex, I'm numbering the articles, I'm picking the first one, and later I can join with my page with the orders and actually unique visitors to get this information, actually name that article one is the one who generated the lead, for example, and I can compensate the affiliate source for that. My current project, it takes a few seconds up to 2 minutes. Up to 2 minutes. So if you have, for example, 7 terabytes of data, it would take around 2 minutes. It would take around 2 minutes. But for that system, you would have a lot of events in the system, and you would split events in different tables, and you would not store in the same table all the events because it gets a huge table. But you can, the same schema of table, you can store in multiple tables. My current project is about the email system for logomix.com. At REA, we implemented a huge scalable system. We have to respond to 100 millions of emails, send that many emails a month, and the customer wanted a heat map. So on the email, you cannot actually do a heat map because you don't have access to the coordinates, but you can track individual links in the email, and you can have all the links measured. And if you wire in all the click events in your system, you can end up using a query to take out which links are performing, and actually you can end up visualizing this on a preview of the email that, hey, this link has that percentage of click rate and so on. There is a versioning at the very beginning of the string. That link may be on the logo or on the footer, so each iteration is actually taken care, first one, second, third, and so on. Okay, normally when you have access to all the open and click events, you can build a lot of dashboards for you that help you. So you can actually detect that you created a campaign that's often marked spam, or there is an ESP deferrer. You probably have heard that Yahoo does a lot of deferring. If you have metrics and you are wiring in your system, you can back off and actually throttle everything to until it gets back to the normal. You can actually do A/B tests. For example, one customer likes blue or red emails, one customer likes this subject, that subject, and of kind of trends. For example, that Barcelona did win the football game, and all kind of engaged users, highly clickers, highly openers, and so on. Our benefits, no provisioning and deploy, no running out of these resources, no more on focus on large-scale execution plans. Imagine Spark, for example, you would start a cluster after 4 hours, no heap space. You Stack Overflow something, you tune in your code, you run it again in 6 hours now, no heap space. And you again try to fix it. It's amazing what a managed service like BigQuery can does. No need to implement tricky concepts in message queue brokers. No more throwing away, expiring, aggregating all data, and this is very important because often customers come up that, hey, I need that report. Sorry, chief, but I don't have the data. I need to first put in, and when I have that data, then I can build a report, but it won't go back in time, the report. But if you aggregate all data, you may have in that JSON column somewhere some information that you can replay and actually answer all the questions. So BigQuery is serverless. It doesn't have indexes, doesn't have sharding, no capacity guessing, either maintenance, manual scaling, no file managements. Actually, 5 or 6 presentations today all discussed how to mitigate these things when you run on-premise system. It's great, right? Okay, so sample projects to try out. There are millions, billions of records out there that you can actually tune in and write your SQL actually to try out the system. I like the GitHub data, so BigQuery did take all the open source, not private, open source projects from the GitHub and actually wire in every commit. And for example, last week I read about features that, a use case that Google detected zero-day vulnerability in an open source project. And it was able to write a regular expression to analyze the code. And in BigQuery, they run a query, what other open source projects implementing the same library have those zero-day vulnerability. And they ended up with 20,000 projects. And they were able to contact them, and they were able to offer support how to mitigate the problem. So fancy things that you don't think that you can do in SQL and with the JavaScript UDF capability. Also, Hacker News is having all the data there, so you can run fancy stuff like what books, what comments, what texts, all sorts of great things. Second screen. If you are a student or you are into the academia, you may find the Medicare, baseball data to run interesting insights for this. You don't need to pay for the storage. You have it as a public. You are running the queries against. So, for example, this query, how much time I have? Let's see, it's okay. So I have here a query that actually used it uses the HTTP archive project's public data, and it tried to find out which pages what frameworks are implementing. And the slides will be on SlideShare. You can digest the query and actually whatever it is here. For example, I can find out what jQuery versions are using websites, for example. It may help me to provide statistical information, or it may actually, again, mitigate a security problem or something like that. And actually, often it's amazing how two libraries, two versions are used on the same website. That's something. Okay, I mentioned Data Studio. Data Studio is generally available since this week. It's a cloud report system, and actually this is a preview from the presentation screen, not mine. It's Google's. And all the information what you have here is drag and droppable and drag and drop creatable. In the behind, all this information is coming from a CQL. If you know SQL, you can write the SQL, or if you don't SQL, you can drag and drop and create the queries and actually end up having something that looks good. Again, I mentioned that your data and other analytics Firebase you can aggregate as well. Someone mentioned encryption before the talk. So with the JSON UDF functionality, you can run and store encrypted content as well. Google in the service level agreement mentions that your data is already encrypted on their server, but if you want to take another example, you can do that as well. So on Coursera this week, a lot of courses started, and you can learn about this as well. And I think this is the last one. I want to run a sample of queries to see how it feels running this. So for example, you know Mr. Dragnea, at least Romanians know. And let's see that if it would let me after this. So there is a database, again, public by the BigQuery team, GDALT, that contains a lot of articles. And actually, I ran here a query that how many mentions they had. It's great to run this before elections. So when you are dealing and you elect people, it's great to run. Why? You can probably guess who is the winner, because population is actually informing by the number of the news coverage. So if they hear 10 times more about one person than the other, then they probably end up creating an idea about that. And actually, I ran this for the Polish elections in 2015, and it was a great guess that the winner is good. So this is an example query. Again, it ran 25 gigabytes, and it processed 12 seconds. So like that. Let's see what else I have quickly on my screen. Let's close this. They should be saved queries here. Dragnea I mentioned. Let's look at the bottom. So for example, let's see Reddit. Edit query. Let me run the query. So actually, I am trying to find out what startup books are mentioned on the Reddit discussions. I define books by those regular expressions, which actually matches an Amazon.com link. And I am able to find out which subreddits and how many times they mention that book. It's amazing information when you are looking for that. And this is just an example of the book, but you may find about, you can design something. Always on Reddit there is a discussion about that. And if you are able to formulate a SQL query, you can find out a trending thing. So Google has that technology trending, but SQL you can do anything from the apple to pear and tomato and so on. So whatever you want there. Good. One more query history. Yeah, it's good. Just I need to scroll back. I want to show you something with the JavaScript, and okay, this one. Edit query. So with this edit query, I actually, let me put that on a new. So actually I have this from cause wrapped in a UDF notation, and I define the UDF here. So this is a minimal simple example, I have the row and I need to emit a response. I have the row meta information as JSON. I'm parsing it. I'm creating a JavaScript object. And in this path of the JSON, I loop for all the services and I emit just the service name. So actually, I have a row where I have a JSON. In that JSON, I enumerated the services, 5, 10, and I want to take out distinct of them. Not by row, the entire database. And this query solves that. So actually, from the full row, it only emits the services, and later I'm running the group by and find out this information. Of course, it's UDF. It has a performance impact, but it will respond and responds me with these events, services, for example, on my data. So actually that concludes my talk. Questions?